Assalamualaikum and a very good afternoon. My name is HAKIM and today we as a group going to present about JK flip-flop. Okay, basically what is flip-flop? Flip-flop is a circuit that has two stable state and can be used to store state information. Okay, basically in a circuit, the output value just depend on the input value. But in a flip-flop, the output value is depend on the input and the storage value. Okay, so this is what flip-flop is in this diagram. Only these two of NAND gate is the flip-flop. Okay, so today what is the function of JK flip-flop is that it want to allow the disallow condition. For example, in the SR flip-flop, there's a condition where when the input of 1, for example, we take S and R as input 1, and the input is 1, and then we get the amount of Q bar and Q is the same, right? Whether 0, 0 or 1, 1. This is the disallow state. So in JK flip-flop, we want to change the disallow state so that we can use it. Okay, by what the flip-flop has done is that the looping of output here in the NAND gate at the second NAND gate, you can see that the output is loop again at the start of the NAND gate at the J, and same goes to here. It will loop to K. Okay, that's all from me. And then the presentation will be continued by three of others, my friend, which is FARAH, LUQMAN, and Afiq. Farah will show you and explain to you about timing diagram, and LUQMAN about truth table, and Afiq about conclusion and the application. Okay, that's all.
Okay, my name is FARAH, AZRINA, matric number 182330. And then now I will explain to you about the truth table. So this depend on, this is the truth table. Clock GK QN plus 1, and then 0, this is the don't care condition. 1 0 0 and 1 0 0 1 0 1 1 1 0 and 1 1 1. So the result will get this QN is in memory condition. This one is reset condition. This one is set condition, and this one is in toggle condition. And then we will go to the characteristic table. After we list 0 0 0 until 1 1 1 condition, and then we will get the result 0 0 1 1 1 0 1 0. It is based on from this truth table. 0 0 we will get 0 0 0, and then we if 0 1 0 1 and the result is 0. When 1 0 1 0 and then the result output is 1, and then when 1 1 1 1 is in toggle condition, then it depend on this QN. We will complement 0, and then this result output will become 1. And the same with 1, this condition, and then this is in toggle condition, and then this will become 0. Then we will go to the excitation table. Excitation table is based on this characteristic table, and then after we list this one, QN plus 1, J and K, 0 0 0 1 1 0 and 1 1, and then for J based on this 0, 0, 0, 1, 1, 0, 1, 1. For this, and then we will get this excitation table. After that, we will do K-map, turn-up map. For J 0, 0, 1, don't care, condition. And then we will get J equal to Qn plus 1. For the K, we will get K, Qn plus 1 bar. After that, we will do the K-map for JK for this characteristic table. And then we get Qn plus 1 equal to Qn bar J plus Qn K bar. So that's for the truth table. Thank you.
Okay, let me continue this presentation. My name is LUQMAN bin SAINI. My meter number is 182535. So now I will explain about the timing diagram. For this timing diagram, I didn't refer to the truth table. So the input is not same exact like the truth table. I just put it randomly. So for this timing diagram, the most important things is we need to refer the clock, which the JK will be functional when we refer to the clock. It will be functions when the graph of clock is from the lower changing to the higher level of graph. So for this graph, I put the dotted line for the changing from the lower to the higher level of graph of clock. So this is the changing. So for the JK, the input of JK, we need to refer the line of the clock, the dotted line. So for this dotted line, the value of J is 0 and K is 0. So for 0, 0, the condition is no change, right? So if no change for the Q, output of Q, there is no change, just remain the value of 0. Since the graph only have two values, 0 and 1, because of the all digital circuit are only required binary number, right? So for the output, the second output of J and K input is we take 1 and this is 0. So the output will be 1. So for we refer this dotted line, but the value of Q, output of Q, we consider the whole area for this area. So for this area, the value of graph is 1. So for the next clock, we refer to J, the value is 0 and K is 1. So we consider the value of J. It depends to the truth table. From the truth table, if J is 0, K is 1, the output of Q will be 0. So this area for this certain clock will be 0. And then for the last one, the value of J is 1 and 1. So this will condition of toggle, which the toggle is mean the value of before the value of before will be toggle, which means we change if the before the value is 0, it will change to 1. If the value is 1, it will change to 0. That is mean by toggle. So for this condition, the value is 0. So it will toggle change to 1. And then the next output is 0, 0, which is no change. So the value of 1 is remain 1. So no change. So for the Q bar is the inverse of Q, which is if the Q 0, the Q bar will be 1. So it like symmetry to the Q. So that's all from me.
Alright guys, now we proceed to the conclusion. Now I will conclude that the JK flip-flop, how to construct the JK flip-flop we have to use consists of a truth table, characteristic table, and also a citation table, just have been presented by Farah just now. So the next is a timing diagram. I will conclude that the timing diagram is also same goes like truth table. So the timing diagram is actually is shown in a graph method, diagram method, shown by the output. It shows the output of the truth table. So alright, we go to the flip-flop application. So what is the application and how does it work? So that the flip-flop can as function to data storage. So flip-flop can store 1 bit at a digital time circuit. So to make it save more storage, we have to put it in series or parallel. So the next is data transfer. Flip-flop can also transfer a data into a mini device. And lastly is counter. Counter is to count pulses or event, and it can be made by connecting a series of a flip-flop. So that's all from us. Thank you.